Okay, 8th graders. Today we're going to look at graphing using the slope-intercept form. And in lesson 12, we were introduced to linear functions. The slope-intercept form is the most common equation used to represent linear functions. It's called this because the slope and the y-intercept are easily identified. And this here on the screen is your slope-intercept form. And let's just take a moment, write this down. Y equals mx plus b, and then let's talk a little bit about each part of this. So let's start right here with this m. This m right here is going to be, most of you probably already know this, it's called the slope. It can also be called the rate of change, and it can also be called rise over run. Now, we talked a little bit about all of these in our last section. All of these things, the change in y over the change in x, that's rise over run, the rate of change, and slope. You'll probably most commonly see it as slope. And then the other thing I want to point out to you is this b value right here. And we've called it a couple of different things, but for all intents and purposes right now, we are going to call it we've heard it called the start value, and we've also heard it called the y-intercept. Okay, those are the two things you're most commonly going to see with that, is the y-intercept or the start value. Now, what does the y-intercept mean? Well, it means that's where it crosses the y-axis when x is 0. Because if you think about this, if I plug a 0 into here, it doesn't matter what this m number is. 0 times any number is 0, which is all it's going to leave you is y equals b. So when x is 0, y is b. Okay, and oftentimes you'll see it written as an equation as 0, comma, b. That's going to be the ordered pair, essentially, for this linear equation, y equals mx plus b. So knowing some of these parts, let's go ahead and take an equation and graph it and see how it all works. So right here in example 1, we have this graph of y equals 1/3 x minus 2, and it says clearly mark at least 3 points on the line. And then we're going to graph it, right? We're going to make a line, basically. So first thing I'm going to do is rewrite this equation down here so we can see it a little bit better. Y equals 1/3 x minus 2. Okay, so let's do that. Let's just bring that right down here so where we can see it and I can scroll down. So here's the first thing. If you remember from that last slide, the first thing you want to do is find the b value. And if you look back here, this b value is right here, or the start value. And that is, one other thing that I like to do is label my y and x axis. So I know exactly y-intercept means wherever it's going to cross this y-axis right here. So I'm going to go ahead and find this -2 value. And notice this is a -2. This sign goes with this number. So I'm going to start right on the y-axis. I'm going to go down 1, 2 from the origin, and I'm going to make a point. That's going to be my b value or start value. Now, from that point, I then do my rise of 1 and my run of 3. So I'm going to start at this value of -2, and I'm going to go up 1, and I'm going to go over to the right, 1, 2, 3. And you say, well, why to the right? That's a positive number. 1/3 is a positive number because there's not a negative symbol in front of it. So this line is going to be positively sloping going this direction. If it was negative, if that slope was negative, the line would run this way. Okay, so I start here at -2 and I go up 1, over 1, 2, 3, and I make a point. That's my rise 1 over my run 3. Then from this point that I just plotted, I keep going with the same slope. I go up 1 and I go over 1, 2, 3, and I put a point. There's my 3 points. I'm going to go ahead and do another one. From this point, I can go up 1, 1, 2, 3, and I have another point. And in order to graph it, I'm going to get my line tool out here, and we're going to create this line. Actually, here's what I'm going to do. I'm going to make it red so you can see it a little bit better. Make it red. Okay, let's make it red so it looks better. And you have this line right here. Now, this line right here, the equation of this line is y equals 1/3 x plus 2. Okay? So that's how, from an equation, you graph a line. Again, find the b value. That's your y-intercept on the y-axis. In this case, it's -2. Then I go up 1/3 because I've got a 1 on the numerator and a 3 in the denominator. Rise over run. Let's look at a couple of more here. We have two equations. It says graph each linear equation. Clearly mark at least 3 points on each line. All right, so let's do 3 points. This one right here looks a little funny. Notice the x is in a different spot than it was in the last one. Here's what I like to do, and you can totally do this. This is not in y equals mx plus b form. This is in y equals b minus mx form. So I'm going to rewrite that because it looks a little better when you rewrite it into y equals mx plus b. So I'm going to do this. I'm going to write it into y equals negative 2x plus 6. That right there is the same equation. Okay, I'll just stick it over here. That's the same equation as that. These two are the same equation. Okay. And then it looks a little bit better. We can find our start value a little bit easier, at least I can. And so let's go ahead and graph this thing. So what do we start with? This 6 right here is this start value, or the y-intercept. So we start at the origin at 0, 0, and we're going to go up because it's a positive 6. 1, 2, 3, 4, 5, 6. And I'm going to make a point. That's my start value right there. Okay. Now, this is a negative sloping line because this slope is negative, so it's going to run this way. As x gets bigger, y is going to get smaller. Okay, so I start at my start value of positive 6. Now, negative means down, and actually you can think of this as -2/1 because this -2/1 is the same as 2, and here's my rise, here's my run. So I'm going to go down now because it's negative. I'm going to go down 1, 2, and over 1, put a point. I'm going to go down 2 more from that point, over 1, put a point. Down 2, over 1. And you see this nice negatively sloping linear line form. And then I am going to get my line tool out again, maybe. And we'll keep it red. And we will graph this line. So what you need to be doing is graphing these lines with a straight edge, obviously, and writing these examples in your notes, and put arrows on the ends of your lines to indicate that they go on forever in each direction. Okay. Let's look at this other one. This one's a little tougher because it's a bigger one. So I've got y equals -7/2 x plus 1. So what I do know is that it's going to be negative sloping, so it's going to look, go the same direction as this line. My points are going to be a little bit different. So let me grab the pen, and we're going to start at the origin, and we're going to go up to the +1. Okay, that's this number right here, +1. That's the y-intercept, crosses the y-axis. Again, this is y, this is x. Okay? All right, now we're just going to go from this point, from our start value. Now we're going to go down 7 and over 2, and it's going to be negative sloping line. So I'm going to start here, and I'm going to go down 1, 2, 3, 4, 5, 6, 7, and I'm going to go over 2, and I'm going to put a point. And now, if I scroll down here, if you'll notice, if I start from this point and go down, I'm not going to have 7 to go down to and over 2. I'm going to be out here somewhere. You can also go the opposite direction. Notice I went down 7, negative, over 2, positive, right here. If I go up 7, positive, I have to go over 2, negative, to keep it a negative sloping line. So let's do that. 1, 2, 3, 4, 5, 6, 7, and over 2, and I'm going to make a point. Now I have 3 points on my line, and we're going to graph this line. It goes down here like this, adjust it a little. And there you have the equation of the line, y equals -7/2 x plus 1. Okay. Both of these, this equation goes with here, this equation goes here. So find the start value, rise over run. Figure out if it's negative or positive. Okay, also in the last lesson we talked about undefined slopes and zero slopes. These are kind of unique equations. I would go ahead and take a minute to draw these and take these notes: zero slope, which means it still does have a slope, but it's 0. And the equation is y equals 2. The reason there's no x involved here is because it never crosses this x axis. So if you want to think of it like this, this is y, that's x. So it never crosses this x-axis, so there's no reason to have one there, right? And it's going to cross the y-axis at a positive 2, so y is going to equal 2. Same way with this one. This one is undefined, okay, because you can't divide by 0 ultimately, and it's never going to cross this y-axis. It's parallel with the y-axis, and it crosses at -1. There still is an equation for this line, but it's where x equals -1, which is right there. Okay, 2 kind of unique type equations that you will see. Now, not all linear equations you connect with a line. Like this one, it says, for example, Jenna started with $50 in her savings account. She adds $10 each month. The linear equation that represents the balance in her savings account is y equals 50 plus 10x. Now, this isn't in y equals mx plus b form like we've known it, so we're going to switch that in a minute. Since she only puts money in her account once a month, a line should not be drawn through the points on the graph. Only the whole numbers and 0 can be used as the x values. This is called a discrete graph because it doesn't have a continuous line. So let's see what that looks like. So right now, take and draw. It's going to be all in the first quadrant. So let's take, I've already drawn one here. Take a minute. You might pause it right now and set up something that looks like this, okay? And what I'm going to do is this right over here is going to be money on this axis right here. That's dollars or money. And then down here on this axis, we're going to have months. Okay. I believe it was months, not weeks. Let me double check that. She only puts money in her account once a month. Okay, she adds $10 per month. So yeah, that's months. This is months.
Is Hayden in food science or fire science? Do you know?
Fire science. Sorry, Mrs. Hayes just interrupted me. So we're back here to months. So this is months, that's dollars. So let's go ahead and start graphing this. Pause it and set something up that looks like this. All right, so now let's go ahead and make some points on this graph. So at this red dot right here, at month 0, she has $50 in her account. And actually, we might start, I'm just going to come up here somewhere. Let's insert that equation so we know what we're dealing with. So the equation is y equals 10x plus 50. Okay. So that equation, let me go ahead and right up here. Let's bring this down so we know what we're looking at. Notice what I did here when I rewrote it. I put the 10x up front because that's the mx, and I put the 50 as a start value. So I pretend this is the 0, 0, right? This, because, you know, if you were to go that way, you'd go negative, and that way you'd go negative. This is 0, 0 right here. So at week 0, or month 0, excuse me, she starts at $50. That's this value right here, $50. That's where you're starting. You're not starting at 0, you're starting at 50. After the first month, she puts $10 in. which means that's $60. So you're going up by 10. Second month, she puts in 70, or another 10, which is 70. The third month, she puts in another 10, which is 80. The fourth month, she puts in another 10, which is 90. And the fifth month, she puts in another 10. There. Now, the reason you do not connect these lines right here is because between 0 month and 1 month, there's a lot of days in here. She's not putting any money in her account right here. She just waits to put it in there, waits to put it in there. There are still days in here, but she's not putting money in. That's why you would not connect those with a line. Okay, so that would be a discrete graph of, I think it was Jenny, her savings account, if she started with $50 and put in 10 each month. Okay, so let's just review really quickly. This is the slope-intercept form of an equation where the slope, the rate of change or the rise over run is this m value, and the start value is the y-intercept. Okay, and then to graph it, you find the start value, like in this example at -2, you go up 1 over 3, up 1 over 3, and you put the points in to graph. All right, you guys have all the tools you need to start graphing using linear equations.